For me, science has always been kind of a form of activism. I always had a detached perspective. But then about a year ago, I found out that a really close friend of mine had the disease. And that really shocked me because the life expectancy of someone with cystic fibrosis is really low. She might only live half as long as I do. And that kind of shocked me and shattered my illusions and really galvanized me to start researching. Because all I knew is that I wanted to help, and research seemed like a really good outlet to do that. So cystic fibrosis is a genetic disease. It's a problem with how we're fundamentally coded. And basically, with cystic fibrosis, there's an error in one of the genes which produces a really important protein. And with the error, it causes lung cells to get super mutated, and it causes them to stop functioning properly. Therefore, it leads to a bunch of secretions forming in the cells and a lot of nasty symptoms like problems breathing, pneumonia, malnutrition. So basically what I wanted to do was that since most of the treatments out there are palliative, which means they only attack the symptoms and not the underlying problem, I decided to make something that could try to correct this mutation right here and make a normal copy of the protein so that the lungs could function properly again. So my first step was to create an enzyme that could correct this mutation and make it function normally again. So basically I went through a lot of incorrect sequences while I was trying to make a new molecule, and I eventually found one that had a high predicted success rate. So I took that enzyme, and then my next problem was figuring out, well, how do I deliver that to lung cells? Because just having the enzyme isn't enough. I need to figure out how to specifically get it to the right type of cell. So basically, I made a nanoparticle, which is like a delivery vehicle to make it carry specifically to lung cells. So then my next step was to test this treatment system in an actual lung cell. So I got a collection of patient-derived cystic fibrosis cells that had the mutation, and then I tested it in there. So basically, I put the system with the same solution as the cells to see if it would correct it. And within less than a week, a lot of the cells were corrected, which meant that they had a correct copy of the cystic fibrosis gene. And so they no longer had the disease in that cell, and the cell could function properly. And even though it corrected only around 10% of the cells, it's been proven before that you only need to correct 6% for the lung cell function to be completely restored. So this could actually be really promising for patients. And while there's still a lot to do down the road, like clinical trials and whatever, since this actually ended up working, this could be really promising for increasing the life expectancy and quality of life of cystic fibrosis patients. Okay, the most important thing to get started in research is to definitely find something that you're passionate about. If you see a subject and you're interested in it, you're definitely going to go for it. If you find something you don't really care about it, you're not going to go as far as you could have if you had actually been passionate about it. So find something you're interested in, throw yourself at that and just pursue it and never give up.